We're going to learn how to use textures in OpenGL, and textures allow us to paint images on our polygons. There are a couple of reasons we would want to do this. The first is more obvious. It allows us to make our polygons resemble real-world objects. For example, to make a face, we could just have a bunch of polygons and paint eyes, a nose, and a mouth on those polygons. The second reason we would want to use textures is less obvious, and I'm going to use this picture to illustrate it. I made this picture, and I'll zoom in a little bit. It's supposed to be a golf ball with a bunch of dimples all over it, and it looks pretty cruddy, but it'll get the point across. These dimples are represented using textures, using images. And what we could have done instead is had a bunch of teeny tiny little polygons all over these dimples. But that would slow things down a lot. It would increase the number of polygons a lot, which slows things down. Now, using textures, this technique isn't perfect. For example, if we were to shine a light almost parallel to one of these dimples, we would expect one side of the dimple to be light and the other side to be dark. But still, this technique is invaluable for computer graphics. And you'll see it a lot in PlayStation 1 and Nintendo 64 games, where they're really trying to make things look good without using lots of polygons. Now, let's go to the program for this lesson. I'm just going to run it to show you what it looks like. And it looks really weird, but anyway, it's just an example of how we can use textures in OpenGL. Now, let's go through the code. I'm going to scroll down to init rendering. And we have this new function called loadBMP. And it just loads in this bitmap file right here into an image object. And the bitmap file vtr.bmp is just an ordinary bitmap file. It's in the same directory as the source code right here. And this is what it looks like. Now, if we're going to use an image for OpenGL, both the width and the height of the image should be 64, 128, or 256, because those are the sizes that graphics cards like. And this particular image is 256 by 256. Now, this loadBMP function is actually in the imageloader.h file, which I made. And let me just show you a little bit about that. It's right down here. It just loads in a bitmap from a given file name into an image object. We could have used a different file format other than BMP. The downside to bitmaps is that they're pretty big. Another alternative might have been JPEG or PNG. But we're using bitmaps because they're relatively easy to load in. In fact, the code for loading in the bitmap isn't all too complicated if you look at it. I just learned about the bitmap file format from Wikipedia and wrote code to load it in. Now, it loads in a bitmap into an image object, and here's the image class. An image has a width and a height, and it has this array called pixels. And the pixels array represents all of the pixels in the image. And what then it goes to the pixel to the right of that, the pixel to the right of that, and so on, all the way down that row. And in this manner, it'll go through every pixel in the image. It'll describe the color of each pixel in this pixels array. And that's basically how the pixels array is formatted. It happens to be a format that OpenGL likes. Now, I'll go back to main.cpp, and once we've loaded this bitmap into an image object, we call this new loadTexture function. And let me scroll up to that. It's right here. And this basically just takes an image object and makes it into an OpenGL texture. So what we do is we first of all call glGenTextures to make room for our texture. The first argument is the number of textures we're making room for, just one in this case. And the second is an array which will store the IDs of the textures. The IDs are GLUINTs, which are basically like unsigned integers. And using some C++ magic, we're sort of turning this variable into an array right here. So once we've made room for the texture, we call GLBindTexture. The first parameter is always GLTexture2D, and the second parameter is the ID of the texture. And this call tells OpenGL which texture we want to work with. And what we're going to do with this texture is we're going to tell OpenGL what the image is for that texture. We do that using a call to GLTextImage2D. The first parameter is just GLTexture2D. The second we'll just leave as 0. These two arguments let OpenGL know a little bit about the format of this pixels array. Then we have the width and the height of the texture. We have just 0. And this tells OpenGL a little bit more about the format of our array. And then we have an array, which stores the pixel data for the image. And this call makes this array right here into an OpenGL texture. And once we're done, we return the ID of the texture. So over here, we just loaded in the texture and store the ID into this variable. And then we can delete the image object, because actually OpenGL made a copy of this pixels array. Texture. Actually, first, before that, we have a call to GLEnable GLTexture2D, and a call to GLBindTexture, which will let OpenGL know the texture that we want to paint on top of our polygons. Now, to explain this part right here, I'm going to, first of all, explain a little bit about texture mapping. So, I'm going to use this picture right here, and basically, whenever we draw a particular pixel that has a texture applied to it, that pixel is going to correspond to a point on this texture image. So it might, for example, correspond to this green point right here. And we need to figure out what color we want to make that point, what color we want to make the pixel. And we have a couple of options. The more straightforward option is just to use the color of the pixel on which this point lies. And if we do that, that'll actually make the polygon on which the texture is applied look kind of blocky. The texture will look blocky. Instead, we could take a weighted average of these 4 pixels that surround the green point, and that'll make our texture look blurry rather than blocky. And I personally prefer that blurry look. But anyway, those are our 2 options for texture mapping. Now right here with this call to GLTextParameterI, actually these 2 calls, we're calling them with GLNearest. And the second call indicates the texture mapping that we're using when the texture is close to the camera. And in this case, we're just using the same texture mapping for both instances. Now, we could have used GLLinear instead of GLNearest if we wanted to use blurry texture mapping instead of blocky texture mapping. You can see what that looks like if you comment out these 2 lines of code and uncomment these 2 lines. After that, we're going to call GLColored3F with this reddish color, and that'll sort of make our image look colored. It'll basically multiply the red component of each pixel on the texture by 1, and the green and the blue components by 0.2. So it'll make the image look reddish. So if you run the program, you see that this bottom image right here is reddish because we changed the color. Then we draw the polygon, and we have this new function call right here, GLTextCoord2F, which indicates where on the image a particular vertex is. So let me illustrate on this picture right here. A texture coordinate of 0, 0 would indicate this location right here on the image, the lower left corner of the image. And a texture coordinate of 0.50 would be right here. This would be 0.80. This is 10. And actually it wraps around. So this is 1.10, 1.20, 1.50, and so on. And actually the texture coordinates wrap around in the vertical direction also. So it's basically like we have this image repeated in the vertical and the horizontal directions. Now, in this case, the vertical direction, so they're repeated vertically also. And they range up to a higher number in the horizontal direction than in the vertical direction, which makes it so that the image looks stretched or squished, depending on how you look at it. Then we're done with textures, so we're going to call GL disable GL texture 2D to make it so that OpenGL doesn't apply textures to our polygons anymore. And then we just do an ordinary colored polygon, which we've seen before, right here. And that's how we can use textures in OpenGL.